Okay, hi everyone. Welcome back to my YouTube channel. So this video is going to be on solving absolute value inequality when you have the greater or greater than or equal symbol. Okay, so let's go over the steps. Okay, so step one, you always want to isolate the absolute value. Okay, step two, rewrite the inequality without the absolute value. After isolating the absolute value, okay, I want you to rewrite the inequality without the absolute value. And remember, when you have the greater than or greater than or equal to symbol, okay, so I want to see two disjoint inequality. So you're going to break down equality to two. So you're going to have greater than, you have greater, and then here you have a positive number, okay, and then you have here, and then you have a less than, okay, and then you have here the negative number. And I'm going to explain, maybe let me write here all. So I'm going to explain why. So when you split, when we write inequality without the absolute value, for the greater or greater than equal symbol inequalities, please write two disjoint inequality. So, and I'm going to show you how, okay? So step three, solve for the variable x. After you write the two disjoint inequality, I want you to solve for x. And then the step four is graph the solutions. Usually when I want you to graph, they will tell you solve and graph. But here for step four, I'm just going to show you how to graph it, okay? So let's go over example number one. Okay, so the first example is absolute value of 3x plus 5 uh, is greater or equal to positive 8. Okay, so step one, the absolute value has already been isolated. The absolute value is by itself on the left side. Check. Okay, it's our absolute value has already been isolated. Okay, so now you're going to move to step two. You're going to rewrite the inequality without the absolute value. Okay, so I'm going to tell you what I want to see. I want to see two disjoint inequality. So the absolute value has been, let me rewrite, has been isolated. Okay, it's all by itself. So I want you to rewrite the absolute value, the inequality without the absolute value. So you're going to write two disjoint inequality, and I'm going to show you why. Okay, so imagine you have a number line, you have a number 0 here at the center. Okay, and let's say, let me assume that 8 is right here. Okay, and the opposite is negative 8. So absolute value, you have two sides to consider, one positive and one negative. So we are asking here, can you find all the number, okay, that have a distance greater or equal to 8? So 8, because equal to, it can be equal to 8. So I have to think, okay, on the number line, okay, where can I find the number that give me a distance greater than 8? So you're going to find out that both number on the right side of 8, all those number on the right side of 8 will give us number greater than, a distance greater than 8. Okay, now in algebra, how do you represent all those number on the right side of 8? Let's say if I assume, let's say take 15. Okay, let's say I assume 15. So compare 15 compared to 8. Is it greater or less than 8? So you see that 15 is greater, right? And remember, 15 represents any number. So I'm just any number on the right side of 8 are greater than 8. So in algebra, you're going to write x greater than, okay, because I'm using the equal sign, greater or equal to 8. Okay, but since I'm not using x here, you're using the expression absolute value of 3x plus 5. So I'm not going to use just x, I'm going to use 3x. So let me rewrite. So it's going to be 3x plus 5 is greater or equal to 8. Okay, so I just wanted to start with a basic example. Okay, and then you're not using x, so both number here, we call that 3x plus 5. So that's why I use 3x plus 5 is greater or equal to 8. Now, okay, can you think also, can you see, can you think of about over numbers on the number line that give us a distance greater than or equal to 8? Okay, so you're going to tell me on the left side of negative 8. So always number on the left side of negative 8, okay, and you continue and definitely, okay, will give us a distance greater than 8. Okay, it's just that they're located on the left side on the number line. Okay, that's why the 8 is negative here. Okay, so now, how do you represent any number on the left side of negative 8? Let me take an example. Like if I choose, let's say, again, let me take negative 15. Okay, so negative 15 compared to negative 8 is what? Is it greater or less than? You're right. Negative 15 is less than negative 8. So you're going to use all those numbers represent x is going to be less than equal to negative 8, right? But I'm not using x here for our example 1. It should be 3x. So I'm going to write here 3x plus 5 is greater, no, is less than equal to negative 8. Okay, so that's why I told you at the beginning for step 2. So after you isolate the absolute value for greater than or the greater than or equal to or just the greater than symbol, okay, so I want you to write for the greater than, okay, you're going to write two disjoint inequality. One, the first disjoint inequality, I said after you write the expression, you have the greater than equal sign, you're going to write the positive 8, okay, the greater than positive 8. Now, for the negative 1, you're going to use the less than or equal. Okay? On the negative 8, you use the less than or equal to. Okay, so that's what I'm going to write right here. Okay, so I want you to see that on the greater than or equal, it's positive 8. Okay, and for the less than or equal, you're going to use a negative 8. That's the two things I want you to see here. Okay, and you see this one matches with this one. So maybe next time to maybe go faster, you can just write greater than or equal to positive 8. Then for the second one, use the opposite. Okay, so let's continue. So now step 3, you want to solve for the variable x. So to solve for the variable x, I need to do I have to do two things here. So first, I'm going to subtract 5 on both sides. Okay. And I have negative 8 plus negative 5 add up to negative 13. Okay, it's negative 13. And then you want to, you basically want to isolate the x here. So you're going to divide by 3 so that the x is by itself. So you get x is less or equal to negative 13 over 3. Okay, so if I want to round it up to approximate negative 13 divided by 3 is going to be around, okay, negative 4.333 repeating. Okay. This is one side of one inequality. So let me do the other. The same principle. So to isolate the x, what do we do here? So please pause the video and do the same. So now I want to undo multiplication of 3. So we divide by 3 on both sides. So now I end up with x is greater or equal to positive 1. So those are the two solutions. Okay. Okay, so the two set of solutions. So how do we graph it? So I'm going to draw a number line. Okay, so I'm going to label 0. And then this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is negative 1, negative 2, negative 3, negative 4. And negative 4.333 should be around here. So because there is a line under the inequality, I'm going to put a full dot there. So this is negative 4.33 repeating. Okay. So the x value needs to add less than or equal to negative 3. So I'm going to shade all those numbers on the left side of negative 3 and including the arrows. And I'm going to draw the arrows at the end. That's what I'm doing right now. Okay. So those represent the solution region. Okay. So let's do the other one. So x is greater or equal to positive 1. 1 is right here. Because x can be equal to 1 because there's a line, and this time is equal to. So at 1, I'm going to put a full dot. Okay. If it was not equal, it would have been an empty dot right here. So x are greater or equal to 1. So I'm going to shade on the right side of 1 because all those numbers on the right side of 1 are greater than. And also I'm going to shade over at the arrows too. Okay. And voila, this is a graphing. Okay, so always if you pick any number in the shaded interval region, okay, we make this absolute value inequality true. However, if you pick any number within the non-shaded area here, okay, it will not be like if you pick first and 0, it will not make this inequality true. Okay, let's check. Okay, if you plug 0 into the x, 3 times 0 is 0, and you add 5 is positive 5. And the absolute value of 5 is positive 5. Is 5 greater or equal to 8? No. It's not. Okay, so that's why if you want the number that will make this inequality true, all the number is number 1, and all the number on the right side of 1, and the number negative 13 over 3, and all the number on the left side of negative 13 over 3. Okay, so I hope the video was helpful. Okay, I'm going to do 2 more examples. Please watch my 2 over videos for you for a better understanding. Okay, bye-bye.